Hi, welcome and to study of non-homogeneous ODE, whereby we have d squared plus 2d plus 1 is equal to y. I mean, multiplied by y is equal to x sine of x. So this has two parts. It has the complementary part plus the particular part. It is what give you us the solution. So first of all, we want the complementary part, whereby we are going to have the reduced form of our equation as d squared plus 2d plus 1 multiplied by y is equal to 0. We let our y to be equal to exponential mx. We differentiate y once to get y. Exponential mx is equal to y prime. We differentiate it twice to get m squared. Exponential mx is equal to y double prime. We substitute the value here. M squared plus 2m plus 1 exponential mx is equal to 0, and we apply the fact that exponential mx can never be equal to 0, meaning that this quadratic equation m squared plus 2m plus 1 is the one which is equal to 0, which can be factorized as m plus 1 here, which is equal to 0. So our m1 is equal to m2, which is equal to -1. We write our solution of our complementary part as c1 plus x c2 exponential -x. Then we come back to our y particular, whereby our rx, our function of rx is a function of v of x multiplied by v of x. In our case, our rx is x sine of x. And now we make use of this general formula. Yp is equal to xv divided by f of d minus f prime of d multiplied by v over f of d squared. We substitute x sine of x over d squared plus 2d plus 1. When we differentiate this once, it is going to give you bracket 2d plus 2 sine of x divided by d squared plus 2d plus 1. Then we square this part there. Then from there now we continue as simplifying it. Yp is equal to x sine of x divided by 1 squared plus 2d plus 1. We substitute the value there, minus bracket 2 cos of x plus 2 sine of x. Here means we differentiate, so I have differentiated the sine of x to get cos of x divided by minus 1 squared plus 2d plus 1. We square this part, which is equal to x sine of x divided by 2d. This will give you -1 plus 1, which is 0. You will be left with the 2d. Then minus bracket 2 cos of x plus 2 sine of x divided by d squared 4. So the next step of this equation here simplifies to minus x over 2 cos of x. When you integrate sine, it is going to give you negative cos of x. So that is why I have negative here. Then minus bracket 2 cos of x plus 2 sine of x. Close the bracket. You divide this by 4 into bracket 1 squared. Yeah. So our yp is equal to minus x over 2 cos of x plus 1 over 4 into bracket 2 cos of x plus 2 sine of x. So now that is our particular part. So our solution of our OD, which was d squared plus 2d plus 1, y is equal to x sine of x our solution of y will be given by y is equal to yc plus yp. Then we substitute our result. Our yc, we found it to be c1 plus c2 of x exponential negative x, then minus x over 2 cos of x plus 1 over 4 into brackets cos of x plus sine of x. You can factor 2 outside. This reduces to c1 plus c2x exponential x minus x cos of x over 2 plus half cos of x plus sine of x, which can be rewritten as c1 plus c2x exponential x minus x over 2 into bracket no x is there, so x minus 1 cos of x. I've factored half outside. This is 1 over 2, and I've also factored cos of x outside plus sine of x. That is over 2 here, over 2. So that is our solution of our given ODE. Remember, you can just leave it at this level. It's okay to leave it this way. Even if you leave it that way, it is correct. So thanks so much for your time. For more such learning, kindly tune on to my YouTube channel so that we may continue learning together. Bye bye. See you in the next presentation.